So the second part of the unit began with solubility and colligative properties. This is picking up after solution stoich as solubility. And solubility is the amount that you can dissolve. And it's dependent on how much solvent you have. It is also dependent on the temperature. It could depend on polarity. That's less important than how much solvent you have and what temperature you're at. If you look at the curve, most of them are solids. You'll know they're solids because they're doing something like that. The gases are the ones that go the opposite direction. So as you increase the temperature, you can dissolve more solid, but you can dissolve less gas. Then we looked at things that affect how fast it dissolves instead of how much can dissolve. You can stir it to make it go faster. That introduces new solvent particles to the solute to make it go. You can do temperature, which is speed of the molecules. And as you speed up the molecules, you get more collisions. Those more collisions will allow it to dissolve faster. Or instead of working the outside, you can crush it up into smaller particles and do the outside of each of those. And that is an increase in surface area. You have more surface. The more surface you have, the faster it will dissolve. Most of the time we spent with the curve, and there's three major types of calculations. If it says how much, it's asking for an amount. Remember on the bottom left of your ratio, it's always 100 grams of water. I want to know how much water, so I'm going to put my X here, is needed to dissolve 35 grams of potassium nitrate. And then it says at 20 degrees, so I can use the 20 degrees and go up to potassium nitrate, which is there. That's at about 32 out of 100. So it's 32 out of 100. I need to know how much water I need to dissolve 35, so it should be larger than 100. And when you cross multiply, you get 110 or so grams of water. I could also ask you about temperature, and if it says at what temperature you want to use the curve always gives you the amount out of 100. If you're not given the amount out of 100, this time you're given there's 135 grams for every 125 grams of water. So then the first thing you need to do is solve for the amount of water. So again, you would cross multiply. Your answer to that is 108 grams per 100 grams of water. That's not your answer. Then you need to find sodium nitrate. You need to figure out where sodium nitrate has a value of 108, so somewhere about there. Then you have to drop down and see the temperature. I would say it's probably about 42 degrees Celsius. The final kind of calculation you have is when it asks what type of solution. And again, you want to use the curve. And the curve is out of 100. It gives you that you did 20 grams per 75 grams of water. So before I can do anything, I need to figure out the amount per 100. That amount per 100 is about 27 grams per 100, and that's at 40 degrees Celsius. So then I would go to 40 degrees. I would go up to 27. I'd put a mark right there. That's where I am, and I'm going to compare that to the potassium chloride line, which is that one. And in this case, I am under the line, so the solution, get off of there, is unsaturated. So those are the three types of calculations. You should have that practice worksheet with you to do some more if these are confusing. We very briefly looked at ice cream, and we looked at that mostly for colligative properties. Those are properties that affect, they're things that you can add that affect the physical properties of a solvent, right? The solvent is the thing doing the dissolving. In most cases, that solvent will be water, but it doesn't have to be. But you add stuff to water, and the big thing is that it keeps it a liquid longer. And the result of that is instead of boiling from 0 to 100, this is the liquid part, it drops the freezing point, it makes the freezing point lower than 0, makes the boiling point higher than 100, so now I have a longer liquid phase. It is dependent on how much solute you add only. I don't care how much water you have, the more solute you add, the bigger the effect.
So then there's this equation that's associated with colligative properties calculations, and that equation says that the change in temperature, that's going to be how much the boiling point or freezing point changes, is equal to I times K, which is a constant, times M, which is the molality. The I is called the Van Hoff factor, which is the number of things that the compound is able to break apart into. And what you have to look at first when you're looking at it is you have to see, is it covalent? Is it made up of all nonmetals, right? Remember that staircase divides where you're at. If you're over here, you got a nonmetal. If you're over here, you've got a metal. If it's made up of all nonmetals, then it doesn't break apart. And since it doesn't break apart, it has an I of 1. If it is ionic, if it's got a metal and a nonmetal, then it does break apart, and it breaks apart into the number of ions that it can break apart into. A couple of examples with that. The first thing I would always do when you're given a compound is I would identify if it's ionic or if it's covalent. Barium is a metal, fluorine is a nonmetal, so that is ionic, and it's going to break into ions. And I like to think of it based on its name. That's the easiest way to count it, in my opinion, is that's barium fluoride. So to break apart, barium fluoride has 1 barium and 2 fluorides for a total of 3 things that it breaks into. Go away, menu. Then you go to the next one. Carbon is a nonmetal, and if a metal is going to show up, it's going to show up first. So anytime you start with a nonmetal, that means everything is a nonmetal, which means that this thing is covalent, which means it's got an I of 1 because it doesn't break apart. The last one, calcium, is a metal, which means this thing is ionic. The name of it is calcium. And then remember, NO3 is a group that you would go look up the name of on the back of that periodic table. It's called nitrate. So what you have is you have 1 calcium and you have 2 of this nitrate group. You don't have a lot more than 2 because nitrate stays together. Calcium nitrate is 1 calcium and 2 nitrates for an I of 3. The rest of the equation, K is a constant. You will be given it. It's Kf for freezing, or it's Kb if it's boiling. And then there's molality, which is the moles of the solute, which is the thing you're given, substance you're given, over the kilograms of the solvent. In our case, we will always use water. And the way that works then is you do moles of solute over kilograms of solvent, and you get the molality. Once you get the molality, you can just plug it into that spot. So those are the 3 things it depends on. Let's look at a couple of examples. Anytime it says something like new freezing point, you know you're using this equation. Delta T equals I times K. In this case, it's freezing, so it's Kf times molality. And I'm going to go start putting things in. The first thing I look at is the I. NH3N is not a Metal, it is a non-metal, so it doesn't break apart, so the I is 1. The K, they give me in the problem. And then molality is moles of solute. In this case, that's moles of NH3 over kilograms of water. They give me 2.32 moles of ammonia. They give me 0.454 kilograms of water. Sorry, my calculator is taking just a moment today. 2.32 divided by 0.454 gets you a molality of 5.11. So then when you look at it, it's 1.86 times 5.11. That's a change in temperature of 9.5 degrees Celsius. Water usually freezes at 0 degrees Celsius. If you add stuff, the freezing point goes down, so the new freezing point is negative 9.5 degrees Celsius. One more example that requires a little bit more work. This is talking about a new boiling point. So it's I times KB for boiling times molality. And I make my way through. This is sodium sulfate. There are 2 sodiums. SO4 is a group called sulfate. There's only one of it, so the I is 3 times the KB. They gave that to me right up there. It's 0.51 times the molality. And here's where I need to do some work, because molality is moles of solute, in this case moles of Na2SO4 over kilograms of water. And I have grams of sodium sulfate and I have grams of water. So the first thing I'm going to have to do is turn 14.1 grams of sodium sulfate into moles. The same way we always turn grams into moles. The molar mass is what you need to do first. And the molar mass of sodium sulfate is 142. Why do you keep doing this to me? 0.04314 grams. You do 14.1 divided by that, and you get 0.0993 moles. So I can put that in for moles. In 1 kilogram of water, there are 1,000 grams. So if I have 324 grams and I divide that by 1,000, I have 0.342 kilograms. 324, sorry about my dyslexia. And it gets you a molality of 0.306. So now we're set up to find the change. And when you do that, you get 0.468 degrees Celsius. So it's not much of a change. Water usually boils at 100. If you add stuff, the boiling point goes up. So the new boiling point is 100.468 degrees. It went up just that little bit, but it went up. And hopefully your grades will go up tomorrow with a good test.